There is a special case with solving inequalities that I want to make sure you're aware of. But before we address what it looks like in algebra, let's talk about what it looks like in arithmetic. So if I have the inequality says 4 is less than 5, I think we all can agree that that is true because on a number line 4 is to the left of 5, which would make it smaller. But let's see what happens if I were to multiply each side by -1. That is a legal move because an inequality kind of operates like an equation, and to balance an equation you do the same thing to both sides. So this is a legal math thing to do. When I do that, I get -4 is less than -5. Here's the problem. If you recall, on a number line, negative numbers are kind of backwards. So -4 is to the right of -5, so it is not less than -5. So this is not true. So in a sense, I have -4 now is greater than -5. So notice how the symbol, the inequality symbol, gets switched because of the fact that negatives are backwards. And I multiplied both sides by a negative. Well, let's talk about what about division. So if I had -12 is less than -10, which by the way is true because -12 is more negative, so it is worse off, so it has less value than -10. If I were to divide both of those by -2, which is a legal move, I'm doing the same thing to both sides, I get 6 is less than 5. 6 is less than 5. That is not true. 6 is actually greater than 5. So again, notice how the inequality symbol switched from a less than to a greater than because I divided by a negative number. So what this looks like in algebra is, suppose I have an inequality that says -2x is greater than -10. So then what I need to do to solve this, I would divide both sides by -2 because I want to find out what times x. And I get x and I get 5. But because I divided by a -2, I have to switch this sign so this becomes less than. Let's graph this just to convince ourselves that this works. So since this says less than, that tells me that the numbers to the left of 5 should work because they are less than 5. So let's test it. So if I use this 4 and plug it in up here, -2 times 4 is -8. Is -8, which is indeed greater than -10. So that is true. So since that's true, this side does indeed get shaded. And because it's less than and can't be equal, I'm going to have an open dot on the 5. Okay, so let's look at another equation. So if I have x divided by -2 is greater than or equal to 4. Notice how the 2 is negative and not the 4. That is the one that's going to make the difference because it's the one with x, not the one without. So to solve a division equation, I know that I'm going to multiply both sides by -2, and I get x and -8, and because that 2 is negative, I have to switch the inequality to a less than or equal. Okay, let's convince ourselves that this is good. So if x is less than or equal to -8, that means these numbers down here should work. So let's try the -9. So -9 divided by -2 is actually 4.5, which is greater than or equal to 4. So since that is true, this side gets shaded since it's less than or equal, and it can be equal to 8, negative 8, it's a solid dot. So let's sum this up. When you multiply or divide by a negative number, the inequality symbol must get switched. Get switched, reversed, however you want to say it so that it makes sense to you. But when in doubt, you can always double check your numbers and test them in the original to see if it's true or not.